Okay, see here. We are going to learn about inductor. Inductor is a coil which contains number of turns. Okay. So whenever current flowing through an inductor, it executes flux, and this flux links with its own turns and produces EMF. This EMF controls the current flowing in that inductor. This happens in a transformer and some of the AC machines. Okay. Now, so we have to learn some of the properties of the inductor. What are the properties of an inductor? So the voltage across the inductor can be given by V is equal to N into d phi by dt. Here phi is the flux, N is the number of turns of the inductor or coil. So and V is equal to V also given by L into di by dt. So whenever there is a change in flux, there is a voltage. Whenever there is a change in current, there also voltage. So can I write I is directly proportional to phi. So only I is the responsible for flux execution. So of course if there is no voltage, there is no current. But sometimes we can directly represent I is directly proportional to phi. This is so somewhat meaningful. Next. So can I write N into d phi by dt is equal to L into di by dt. If there is a uniformity, then N into phi is equal to L into I. Then L is equal to N phi by I. This is one of the form of finding inductance of a inductor. Here N phi, N is the number of turns, phi is the flux in Webers, I is the current in amps. Okay. We can further find this inductance in terms of magnetic permeabilities. So we know that phi is equal to mmf, magnetomotive force divided by reluctance of that circuit. So reluctance is the air gap reluctance. So we can consider only air gap reluctance. If there is core, the reluctance is negligible. Okay. So reluctance R is equal to L divided by mu naught mu R into A. Okay. Next, that is equal to, here mmf is equal to N into I. So phi is equal to N into I divided by R, that is equal to N into I divided by L divided by mu naught mu R into A. So that can be written in the form of N into I into mu naught mu R into A divided by L. Substitute this phi value into this equation. You will get L is equal to N square mu naught mu R into A divided by L. This is the another formula for finding the inductor. Here L is the length of the inductor, A is the air gap area. Okay. Next. Once again. So next we are going to learn about the voltage and current relationship in inductor. In practice, we are saying that the current lags the voltage across the inductor by 90 degrees for an ideal inductor. For a practical inductor, it may be 80 or 85 depending upon the resistance in the inductor. Okay. So how we can say? So here, when I am taking I is equal to, so since let's take I is equal to current flowing through the inductor, I is equal to Im into sin omega t. Here omega is the angular frequency Im is the maximum current. Now V voltage across the inductor, I VL. So V is equal to L into di by dt. Is it? So that is equal to L into d by dt into Im into sin omega t. That is equal to L into Im into omega into cos omega t. Is it? See here, there is a 90 degrees deviation between the input and output. Because input is a current, output is a voltage in an inductor. Can I write sin theta sin omega t is equal to cos of 90 minus omega t? Is it? That is equal to cos of omega t minus 90 degrees. Since we have taken minus, cos of minus theta is equal to cos theta. So see here. So V is equal to, and I is equal to Im into cos of omega t minus 90 degrees. So current lags by 90 degrees. This is the phasor diagram of inductor. For an ideal inductor, I, this is voltage. Okay. If phasors are rotating, to avoid confusion, see here, if phasors are rotating in the anti-clockwise direction, this direction, we have to sit here calmly and see which is come first. If you are rotating, so you should rotate in the clockwise direction and you will see the voltage first and then I. This is the one method, one trick to avoid confusion. Okay. So can we use inductor to modify voltages, to convert current into voltage, or to modify the current waveform and to get voltage? This is possible somewhat. See here, whenever you want to modify a current waveform and to get voltage, you pass that current waveform through an inductor and that current can be passed through a resistor. If you observe voltage across the inductor, you can get the modified current waveform across the resistor. Okay, you can get only because current and voltage are in phase in the resistor, so we will get the modified voltage waveform in the resistor. But this is a somewhat difficult, somewhat lossy process because the loss in the resistor is accommodated. Instead using this element, this inductor, we can use op-amps, some active elements, that is op-amps and transistor circuits. That is one method to modify the input voltage. So usually the voltage across the inductor is a differentiation of current. If L is equal to 1 Henry, we have taken, then voltage is equal to V is equal to L into di by dt. So di by dt. So there is a differentiation property. Okay, this is one. Next, what is the power through the inductor? So P is equal to V into I, that is equal to I into L into di by dt. That is equal to L into I di by dt. So this is the power across the inductor. Instantaneous power. If you want average power, so you have to integrate and through an t. So period t. So net power consumed by an inductor or net energy consumed by inductor by an ideal inductor is 0, because there is no energy consuming elements like resistor. So if you take, so I will prove now. So net energy consumed by an inductor is equal to 0. See here. So I is equal to, so current flowing through inductor I is equal to, so what is, so Im sin omega t, is it? So V is equal to Vm cos omega t, is it? So power P is equal to V into I, that is equal to Vm Im sin omega t into cos omega t. Take 2 by 2 on both sides. So 1 by 2 Vm Im to sin A cos A is equal to sin 2A. This is the formula we can use here. So sin of 2 omega t. So average power P average is equal to 1 by 2 into integration of 0 to, usually the period of sin or cos is about 2 pi. So we can take directly 2 pi. So Vm Im sin 2 omega t d omega t. Okay, 1 by 2 Vm Im minus cos 2 omega t divided by 2 whole power of 0 to 2 pi. This will give 0. How? So 2 pi minus, so minus into plus plus cos 0 1, so 1 by 2 minus 1 by 2 0. So this is one form. You can prove directly in this way also. Energy stored in an inductor in a period, in a particular complete period, is equal to 0. Okay. Now we have to find what is the energy stored in the inductor. In a period it will be 0, but when current or voltage is maximum, then maximum energy stored in the inductor, energy E is equal to P integration of 0 to T P into dt. So we will observe up to T. So what is P? So integration of 0 to T I into di by dt L into dt. So here P is equal to 0 to T V into I we have taken into dt. So I is given, so V is L into di by dt. So I into L into integration of 0 to T di, is it? So see here, I taken here. So 1 by 2 L into I square. So energy stored in the inductor. This is. Now, we oftenly seen that the current through inductor should not change instantaneously. Why? So actually, the current flowing through the inductor should not change instantaneously means there should be an infinite amount of voltage should be applied across the inductor. How see? So V is equal to L into di by dt. If current changes instantaneously means within a 0 span of time it has to change. So dt is equal to 0. That is equal to L into di by 0. Number by 0 is equal to infinity. So V is equal to infinity. So we had to substitute infinity amount of voltage across the inductor. Then you will change the current through the inductor instantaneously. This is the one of the property of the inductor. Now, so next, when the inductors are connected in series or in parallel, what will be the net inductance if there is no mutual coupling? And if these are two are inductors connected in parallel, and then what will be in series, then what will be the equivalent inductance if there is a mutual inductance? So usually resistance and inductance are similar in voltages actually. So here inductors are connected in series, both L equivalent is equal to L1 plus L2 if there is no mutual inductance. No mutual inductance. If there is a mutual inductance, so then there will be some other formula that is given by L1, L2, L equivalent. L equivalent is equal to L1 plus L2 plus or minus 2M. Here M is a mutual inductance. It can be given by M is equal to K into root of L1 plus L1 into L2. Here K is called coefficient of coupling. So its value is less than 1. For an ideal, it may be equal to 1. So ideal means, so entire flux executed by the inductor 1 or coil 1 will links with entirely coil 2. There is no leakage in the inductor 1. Then only K is equal to 1. So usually K less than 1, it's about 0.9, 0.8, depending upon the leakage fluxes between the inductor 1 and inductor 2. So whenever the coils are aiding in means, so their resultant fluxes are in phase. Their resultant fluxes are in phase. Then they are aiding to each other. Then we will get plus 2M. So equivalent inductance L1 plus L2 plus 2M. If they are opposing in each other, so means one of the coil executes opposite flux, then there will be minus sign will come here. Detailedly we will learn the magnetic circuits in next other classes, next chapter. So this is the fundamentals of inductor. So actually inductor coils. Next we will learn some of the problems in the inductor. Okay, then we will go to some other topics. Next, we can use this also in the star delta form. So in star delta also, simply you can replace inductor with resistor. Do the manipulations. This is a simple. In a capacitor, there is a somewhat reciprocality is there. We will use that. Okay. So do problems now. Once again. Okay. Here are some of the problems. First problem. Here I is given, L is equal to 200. Find the inductance and average power across the inductor. No. So this is problem. So I is equal to, so we have to find the instantaneous power and the average power across the inductor. So first one is, so I is equal to 100 sin omega t. Next, L is equal to 2 henries. So he has given two data. One is current through the inductor and the L is inductance of the inductor. Next, we have to find P instantaneous, power instantaneous, and P average. Actually, we know that P average across the inductor over a period, complete period, is equal to 0. Next, P instantaneous we have to find. P instantaneous is equal to V into I. Instantaneous voltage into instantaneous current. What is instantaneous voltage? V is equal to L into di by dt. I is given and L is also given 2 into d by dt of sine of omega t, that is equal to 2 cos omega t into omega, because differentiation with t we have taken, so 2 omega cos omega t, that is equal to Vm cos omega t. P instantaneous is equal to Im into Vm into cos omega t into sin omega t. This is instantaneous power. Okay. Next problem. So here one circuit is given. We have to find equivalent inductance. That circuit is this is circuit 2 Henries, 2 Henries, 2 Henries, 2 Henries. So we have to find L equivalent. See here, these two are in series. We can write directly L equivalent is equal to 2 plus 2. So see here, I will give this equivalent into next circuit. So can I write here 4? Here 2 is in 2. Next L equivalent 1 by L equivalent is equal to, I am using fundamental formula because here 3 elements are connected in parallel. So 1 by 2 plus 1 by 2 plus 1 by 4. Take LCM for 2 plus 2 plus 1, that is equal to 5 by 4. 1 by L equivalent. That implies L equivalent is equal to 4 by 5. This is the equivalent inductance of the circuit. Okay. Next problem. So here one equation is given, voltage in terms of distribution, binomial distribution, or a Taylor's expression is given. So see, identify that voltage and give the answer. So I is equal to, given in this form, Im, okay, 50 into 1 minus omega t divided by 1 factorial omega square t divided by 2 factorial plus omega t whole power of 4 by 4 factorial minus omega t whole power of 6 by 6 factorial plus and so on. So it is in the form of cos omega t, is it? So cos omega t, using Taylor's expression, you can distribute this. You can expand cos omega t in this. Use Taylor's theorem or Lagrange's theorem. Any one of them. Okay. Next. So I can write I is equal to 50 cos omega t. He asked that we have to find the voltage. So V is equal to L into di by dt. Substitute I and differentiate, will get voltage. So he has given L is equal to 1 Henry, or you can put L like that. Okay. Next question. This is somewhat typical. Fourth one. So see here waveform is given. This waveform is given to you. See, so this is I of t varying between the 0 to 10 seconds. 0 to 10 seconds. Okay. Inductance of this inductor L is equal to 2 henries are given. 2 henries, not millihenries. Here also t is not in milliseconds, it is in seconds. Okay. For simplicity we have taken this. Next. So here current is given, we have to find the voltage waveform in the inductor. See, we can find voltage waveform directly in this way. So while we are taking section wise. So first section, take 0 less than t less than 2. Okay. So in this section, so I have taken this section only. Substitute. So since V is equal to L into di by dt, is it? So what is the change of current from 0 to 2, and what is the change of current we have to find. Since di by dt is nothing but the slope of current, any waveform if you differentiate it and substitute at 0, then it will give the slope of that line. Okay. If I have y is equal to mx plus c, if you differentiate it, you will get dy by dx is equal to m into 1 plus 0. So m is equal to dy by dt. This is linear equation, so slope is equal to, is it? This is in the form of y is equal to mx plus c. M is a slope, x is a variable, and c is a constant, y is a variable. If you take second order system, y is equal to x square, so dy by dt is equal to 2x. So if you substitute this, you will get the tangent of that curve at particular point. If you substitute 0, 2, you will get the tangent at that point. Okay. Since here it is a line passing through origin, we can write, or you can find this equation. Is it this equation? What is here? What is the point here? Your point is 2, 10. Here 0, 0. You can find a slope y is equal to, slope m is equal to y2 minus y1 divided by x2 minus x1. That is equal to, what is y2? 10 minus 0 by 2 minus 0, that is equal to 5. Now V is equal to, so what is henries? 2 into 5, that is equal to 10 volts. Okay. So voltage waveform in between 0 and 2 is directly can be written, see here. So 0, 2. So this is directly 10 volts. Next we are taking the section 2 and 4. So now take it 2 less than t less than 4. Now there is no change in current, is it? So there is no change in current, so their voltage V also 0. So from this equation, there is no change in current means di by dt is equal to 0. So V is equal to L into 0, that is equal to 0 we get. Next, so this is V is equal to 0 for 0 less than t, 2 less than t less than 4. Next we are taking the equation, the part, next step is 4 and 6. So next take this part, that is 4 less than t less than 6. We have taken this part. See, here this is the line passing 4 comma 10 and 6 comma minus 10. Can we find slope m is equal to y2 minus here 2, here it is 2, here it is 1, so it is falls from this point to this point. So take it. So m is equal to y2 minus, what is y2? Minus 10 divided by x2 minus x1. So this is x2, 6 minus 4. That is equal to minus 20 by 2, 10. That is equal to minus 10. So here slope is k minus, because slope is downward. Here slope is increasing, that's why we have got positive slope. Here slope is downward, so we have got minus. If this line equation, if this slope also we have got plus, means we have done wrong somewhat. Okay, next. So V is equal to 2 into minus 10, that is equal to minus 20 volts. Similarly, the current change in the 6 and 8 is 0, and from this also 8 and 10 there is a slope of same line. So we'll get directly this. Here minus 10 will come, minus 20 is it? So here minus 20 volt come. This is 0 from 6 to 8. Here it is 4, here 6, here 8, here 10. So from 8 to 10 there is a positive slope of increment, even though it is in negative side, but slope is increment, so we'll get positive voltage. So this is about 10 volts. This is the voltage waveform of the inductor. Okay, next we will come to next class.